Okay, this is AP Statistics. My name is Deborah Brown, and this is FRAPPY number 3 solution. So we're going to be discussing the normal model, normal CDF, inverse norm, transforming data, and the 6895997 rule in this FRAPPY. Okay, so for the first question here, it gives you the mean of 22. It gives you the standard deviation of 4 and asks what proportion of students scored at least 25 points. So there's 4 steps. And the first step is to draw a picture. And the picture is going to be normal model 22, 4, and then 22 here. So I'm going to go ahead and put the first standard deviation just so you can see that 25 is a little bit more or a little less than one standard deviation. But that's the percentage I'm looking for, y percentage or question mark percentage. So that's step 1. Step 2 is to write my probability statement. So this probability is that I'm looking for some x that's in the shaded area. So that x is greater than 25. And that probability is that z is greater than, I'm changing this to my z-score, which remember my z-score is observed minus mean divided by standard deviation. So my observed value is 25 minus 22 divided by 4. And if you want to go ahead and solve that to 0.75, you can, but that's not necessary unless you're going to actually be using your chart. So I'm going to be using the calculator of normal CDF. So my step 3 is to show my work. So normal CDF, and I'm doing lower bound 25, upper bound infinity, mean 22, and standard deviation is 4. If I chose to do my chart, I would say, okay, I'm doing the chart. I've got a z-score of 0.75. And then when you put this in, you're going to still get about 22%. So either way, you're going to get about 22%. So step 4, you're going to put about 22.7% of the students scored greater than or equal to, because it says at least 25 points on the test. Okay, letter B. Again, we have 4 steps. Step 1, it asks for the 31st percentile. So here's a picture. 31st percentile is going to be somewhere between 0 and 1%, so that's going to be 31%. I don't know that value of y. That's my first step. My second step is to write my probability statement, and the probability statement, remember, my x is somewhere in this shaded area, so x is less than y, and the probability, let's go ahead and make this to z. Z is less than y minus, the mean is still 22, and the standard deviation is 4, so I've converted that to a z-score, and we do know that's 31, so the whole statement. The next step is going to be, if you're going to go ahead, and I'm going to do both ways for you. So if you do a calculator, it would be inverse norm. The area is always from the left, so that's 31%. So because I'm in the 31st percentile, the mean is equal to 22, and the standard deviation is equal to 4. Notice sometimes I write this and sometimes I write this. That's fine. You can write SD for standard deviation, or you can write sigma, which is the population standard deviation, which is what's the symbol on your calculator. And then when you get this, you're going to say step 4, and you're going to say about, and it gets to be about 20. So about 20 students lie in the 31st percentile. If you did this by hand, because if you're grading someone that did it by hand, the way you're going to have to make sure you do is that you're going to have to first of all find y minus 22 over 4, and you're going to have to find the z-score for 31%. So to find the z-score for 31%, let me go ahead and show you how to do that. You go inverse norm, so menu, stat, distribution, inverse norm, and you would do, okay, 31%. Or you could do it on your chart, and you get negative 0.495. So that's going to be negative 0.495. And then when you do the math, you're going to get something really similar to what we got here, you are going to get 4 times 0.495, negative 0.495, and then you're going to add 22 to get it, and you're going to get something close to 20. You get like 20.02, which is very similar. So either way, so when you're grading the papers, either this method or this method for the work, okay? All right, for letter C, we're going to be transforming data. So the thing is that I've got the teacher is now wants a mean of 80 points and a standard deviation of 10 points. And remember, the old mean was 22 points, and it wants the new mean to be 80 points. And the old standard deviation, it has as 4 points, and it wants the new standard deviation to be 10 points. Okay, so what I'm going to do is realizing that when I'm adding anything, so when I'm adding A, for instance, the standard deviation doesn't change, because all I'm doing is if I have this data here, and let's say I add 4 to it, I would be adding, let's say, let's say this is the range of the data. That's the minimum, and that's the maximum of the data. And doesn't matter what this distribution is something. And if I add 4, it's just going to be now from here to here. So the standard deviation doesn't change when I'm adding, but it does change when I multiply, because let's say now if I multiply all this original by 2, instead of it becoming here, it's going to be becoming twice as big. So having said that, I know that the mean changes when I add or multiply, so I'm going to first figure out the mean, and then I'm going to adjust it with the standard deviation. So I notice though, I'm going to first do the standard deviation since it doesn't change with adding and subtracting. So first of all, I'm going to notice that 4 times something is equal to 10. So I'm going to find out that 4 times, obviously it's going to be 2.5, is equal to 10. So what I'm going to do to my old standard deviation is multiply it by 2.5, and that's going to get me 10. Now I can take and I can adjust my mean to get 80, and the way I'm going to do this is I'm going to do 22 times 2.5, because I have to multiply it by the same thing. And so 22 times 2.5 is 55, but I have to get to 80. So how do I get to 80? Well, then I'm just going to take 80 and I'm going to add 25. Take 55 and add 25. The reason I'm going to do that is because if I add 25 to the standard deviation, nothing changes. Remember, it just shifted. So the first step, what I did is I found the factor that I need to multiply to get the standard deviation, and then I adjusted it for the mean. So, and I would say, and so my answer, my new score, is going to be 25 plus 2.5 times the old score. And again, I'm going to say that the standard deviation adjusts when, or changes, I guess, when multiplied or divides, and the mean changes when multiplied, divided, add, or subtract. So step 1, I found the standard deviation. And then step 2, I used the factor that changed the standard deviation and then added my number B, or 25, so I can get 80. Okay? So, and then B. So this is what we're going to do, is it gives me a maximum. Here it says the maximum score was 10. So the maximum is equal to 10 points. But it gives me a mean of 9.2. And it gives me a standard deviation of 2.1. Okay? So I know if it's normal, it says, would it be appropriate to use a normal distribution? Well, if it's normal, I know that this would be 9.2. And let's keep going. 9.2 plus 2.1 is going to be 11.3. Plus 2.1 is going to be 13.4. Plus 2.1 is going to be 15.5. So if it's normal, it's going to look something like this on the right side. I could do the same on the left. I don't need to because it's talking about maximum points. So 10 is going to be somewhere right here. So clearly, this is not going to be normal, because 10 is not even 1 standard deviation away from the mean. And we expect our maximum to be about or more than 3 standard deviations above the mean. And it's definitely not. Okay, hope that helped. And go ahead and do the scoring to be able to see the rubric.